Hello and welcome to lecture 2 of the BitBadges Token Standard course. In this lecture, we'll focus a little bit more about the balances interface and the different balance types and kind of side by side compare them to analyze the pros and cons of each method of implementation or storing balances. So let's start with the balance interface because that is used across all balance types. So you can see here that it is a threefold interface. So with existing token standards, or what you might be used to, is only a twofold interface. So normally you would just have amount owned for each token ID, or badge ID in this case. However, we add a third element, called the ownership times. So pretty much you own a badge, you own this amount of this badge for these times. So this allows you to implement the time-dependent balances that we mentioned previously. For example, token unlocks or lending or memberships that auto-expire. So you can customize when a user owns a certain amount of badges and how long they own those badges for. So when kind of interpreting this, you can think of it as like a nested for loop. So a user owns this amount of this amount of these badge IDs for the following times. So you can see in this example, the user owns times 1 of badge IDs 1 to 10 and IDs 20 to 30 from the times 20 to 50 and 100 to 200. Normally the times would be Unix timestamps, but we kept them small for simplicity's sake. So it's easier to think about when you're looking at it from this perspective, but it gets a little complicated when you try to subtract or add, because if you only subtract the balances for a certain time, you might still own the balances at other times. So you can pause the video here and just kind of look at what the docs say, or go to the docs and then balances, core concepts for developers, and just kind of go through these thought experiments. Pretty much when you subtract balances, you might still, it's a little weird doing the math for it. It's just something to get used to because it's threefold instead of twofold. So we recommend using the SDK also, because it handles everything for you. So if you just go here, you see the balance array from, or you can add certain balances to subtract balances. It all handles it for you behind the scenes. Okay, so now that you understand balances and the interface behind balances, now how do the actual transferability, the balance types work? So there's 3 different balance types: on-chain, off-chain indexed, on-demand, and you can also just have no balances too. If you want to pause the video on all these explanations, you can, or you can go to the docs for further explanation. But the overview of each is that on-chain balances occur on-chain. All balances, all transfers take place on-chain, must have sufficient balances, and follow the necessary on-chain approvals. It's the most decentralized, but it's also the least scalable because it uses the most blockchain resources. With off-chain indexed, balances are actually stored on a server. So you have a full key value map. Let me pull an example up. And they're just managed by however you want to control them on your server. So this could give you a lot more customization, and also it doesn't use blockchain resources like transfer transactions or approval transactions, because it's all hosted off-chain. So as you see here, we map everything to a Cosmos address, and each Cosmos address has a certain balance map that it owns, pretty much. And the entire kind of ledger or entire allocation must be in this one map at a single endpoint. So that's kind of why it's indexed, just so we know that all the changes from time A to time B, all owners at any point in time, and so on. The third is on demand. Basically, you can set certain criteria that you must own, or if a user meets that criteria, they will automatically get those balances. So one of the examples that we had from the last lecture was the first Ethereum transaction. There's no one endpoint that just hosts all the balances of all Ethereum users. We calculate this on the fly. So if we go to the italic, you can see we calculated that on the fly, determined when his first transaction on the blockchain was, and then assign the badge ID 1 based on that. So for example, let me pull up the code for that. Let's see, is it here? think it's down here actually. So I don't know why that's not working. There we go. So as you see here, it's just a simple like endpoint that we call, and pretty much badge ID 1 was 2015. We look it up from an API and then just assign the respective badges on demand based on what the API says. And yeah. So the key difference here and between those two is that the as you see, the actual address itself is a, sorry, I can't get it to highlight, but as you can see, there's a placeholder for the address right here. So we dynamically query the address based on, or the address's balance is based on the endpoint. It's not just one endpoint that we host the whole map, it's just we calculate on demand by address. So different trade-offs because, you know, for one, you might need to know the entire balance history or all the owners at one time. So you might need index balances for that. Or if you want it to be like super scalable and like on demand, use the on demand type. So other than the where it's hosted, you also have to consider the like kind of how it's hosted. So, you know, the availability, the decentralization nature of it, how scalable it is, and also like the user experience. So in terms of user experience, you know, for on-chain transfers, they have to interact with the blockchain, which might be a little bit of a learning curve or a little not as optimized. Whereas off-chain, you can update balances for free as you wish because it's all stored on the server and you just update the stuff on the server. Nothing on the blockchain actually changes. And as a result of being, you know, indexed, as in the case of the index type or on-chain balances, we can do certain things with that. You know, if it's indexed, we can show it in search results. There's a known total supply, and there's like we can put together a ledger of activity. So just differences in balances over time. However, for non-indexed, these are not applicable because if we don't know the owners and amounts at any given time, we can't actually put together that ledger completely. So again, I'll leave it kind of here with regard to the comparison table. So if you want to pause the video and look more into this, yeah, you can kind of see the side-by-side trade-offs of all the different types. The last thing I do want to note is that you might be worried about the decentralization aspect of off-chain. However, what you can do is actually make it, as you see here, if your collections badges, you can make it always verifiable, always permanent, immutable, and so on if you do two things. So the first thing is to set the permission for updating the URL on-chain to be frozen, so the URL is always permanent on-chain. And then if you use permanent storage like IPFS, they're hash-based, so you can always verify the hash. So if you have a balances map with the hash, you can always verify that the balances map hashed equals the IPFS hash on-chain, and thus, you know, the balances are permanently frozen, and then always verifiable, always available, and there's no like central trust involved or centralized entity controlling the balances. It's all just cryptographically secure that it'll always be like that. So that is an alternative. You might even choose to, you know, initially have the balances updatable, and then once they're final and permanent, switch to this permanently verifiable approach. So again, lots of different trade-offs, lots of different things you can do with each approach, and I'll also refer you to this page here, the balances type page, for a more developer oriented explanation. So pretty much, it's a big decision you have to make when creating your badge, but a lot of benefits and trade-offs to consider, and one of them will be probably the one that you should use for your use case, and it'll kind of stand out over the other.